Alright, parallelograms. Parallelograms, including squares and rectangles, are everywhere around you, and you're going to be able to prove special relationships about their sides and angles. A parallelogram is a quadrilateral, so just a four-sided polygon, but it's got a lot of special properties that are a bit different than some of the others. Alright, so some of the properties that all parallelograms have. Property 1, both pair of opposite sides are parallel. It's kind of how it gets its name. Opposite sides are parallel. That's what those marks mean. The second very special, or something special to parallelograms, is both pair of opposite sides are congruent. So these two are the same length and those two are the same length. Another property, one pair of opposite sides is both parallel and congruent. So if these two are the same length and these lines are parallel, you're looking at a parallelogram. Both pair of opposite angles are congruent. Okay, I don't know if you can tell the difference in color. These are blue angles, they match each other. So angle A is congruent to angle C. Angle B is congruent to angle D. What you've got to think about here is if these are parallel lines and transversals to each other, then what we get here is alternate interior angles. Okay, diagonals of a parallelogram bisect each other. So that means that at the point that they cross becomes their midpoint. So this is a midpoint of this long diagonal here, making this segment equal to this segment over here. And last, consecutive angles in a parallelogram are supplementary. Okay, so you end up with four different pairs of angles. A plus B add up to equal 180. These would be consecutive interior angles if we're talking about parallel lines in a transversal. So B plus C equals 180, C plus D equals 180, D plus A equals 180. Consecutive angles just means the very next angle if you were traveling around the parallelogram. Alright, so these properties can be used to be asked a lot of different questions, or different in how I wrote it. Sorry about that. Questions in geometry. Alright, so some examples. You might be asked to solve for x and y in a parallelogram and given a picture that looks like this. So it tells you that this is a parallelogram. So we're going to know that because I know for a fact this is a parallelogram, alright, I know that the opposite sides are congruent to each other. So to solve for x, I set those opposite sides equal to one another. And just solve for x the way we know how, and 9.5 equals x. Alright, so again with the properties of parallelograms, I know that consecutive angles are supplementary. That means that that first angle, 6y plus 5, added to the second angle, 10y minus 1, equals 180. So now we just solve for y. You add those like terms, do your subtraction and division, and you end up with y equals 11. These will be the first kind of problems we work on when we're working in class. Okay? Sometimes they're asking for more than just a solution to the variable. Okay? Alright, so here we go with given this parallelogram, find each measure. And it gives you some labels here. Now, what we know about parallelograms is that the diagonals bisect each other. So I know that these two pieces are equal to one another, and I know that these two pieces are equal to one another. So to find JG, which is just this little segment right here, I need to find W first, okay? But it's asking for the measure of JG, so I have to plug 4 back into here. So I set them equal to each other, solve for W, and then plug it in. Alright, the next segment it's asking you for is FH. Now FH is the entire diagonal. Okay, so again, I've set the two pieces equal to each other, I solve for Z, I plug it back in to just the JH part, and then I need to multiply that whole thing by 2 because I know this segment is equal to that segment. So the length of FH equals 18. So those are two examples of the types of problems we'll be doing in class tomorrow.